this okay? Good. Thank you. That was a very generous introduction. Hope we can live up to it. What we're going to talk about tonight is, as your associate director said, is work that we've done on the effects of gas drilling, presumed effects of gas drilling on human and animal health. I'm a little bit intimidated here tonight because, normally what we say is that animals are great models because they're sort of sentinels for human health. And one of the examples we give is that, well, it's really hard to get 100 pregnant women near a drill pad and study the effects on their health. But we can get 100 female pregnant cows near a drill pad and study effects. But here, you dwarfed us by studying the invertebrates. You have much larger sample sizes, and I'm very impressed by that. And I think this is really the way to go. I think we're going to learn a vast amount of information from your invertebrate studies. Okay, so I usually start these talks by a somewhat provocative slide. I hope it's not too provocative for here. This isn't meant to build this wall. This is actually meant to break the wall down. And the statement that I like to start with is, since it was used for the first time in the 1940s, hydraulic fracturing of natural gas well has never been proven to contaminate drinking water. And then I asked the question, is this true or does it matter? Okay, that's probably enough to get anybody upset, no matter what side of the wall you're on. But what I mean by this, well, is that what are we talking about here? What does is proven mean? What is the nature of proof? And what are we talking about when we say hydraulic fracturing? I think a lot of times when you hear this statement mentioned, people are talking about just the process of fracturing the rock. That's the people that were on this side of the wall. People on this side of the wall are talking about the entire process. Okay. We don't have that many examples, maybe 3 that I can think of, where we have really good evidence that hydraulic fracturing itself, just fracturing the rock and breaking it up and releasing by the hydraulic fracturing fluid has contaminated drinking water. I can only think of 3 cases where it's been pretty well shown. But there's a lot of pretty good evidence that the whole process can have impacts on our drinking water, perhaps, and our health. And so when I say, does this matter, I'm referring to hydraulic fracture. Does it really matter to say that the process of breaking the rock hasn't contaminated drinking water? Probably not. What we really want to look at is the entire process. And the entire process, I'm talking about drilling. This is where, by definition, the aquifer is contacted by drilling. The hydraulic fracturing process itself, trucking. Unfortunately, I have to admit that I took this picture while driving in Susquehanna County. I guess I could have got the ticket for that. The impoundments, condensate tanks, and pipelines. And most importantly, the one thing that we have to remember is that wells are there virtually forever. And we have to know about what happens to them, not 5 years from now, not 10 years from now, but 100 years from now. And at least one of the cases that I know of where there's good evidence that the fracturing process contaminated the aquifer is because of the existence of an unknown abandoned well. So we need to consider all these aspects when we're considering the effects of human and animal health. And so what our study really does here, well, the way we look at it is from the point of view of biomedical researchers. We're not so, our background really isn't in environmental sciences, it's in biomedical research. And when you think about how does one go about studying a problem, or say a disease outbreak, What comes to mind generally to me is like the AIDS epidemic. How was that studied at first? Well, the CDC identified cases, individual cases of gay men with Kaposi's sarcoma in San Francisco and published case reports. We went on to epidemiological studies. Finally, the virus was identified, drug targets were identified, drugs were developed, and a lot of progress has been made. But it started with case studies. And that's really where I think we are now, at least our work, is seeing where exposures might occur, what things could occur based on case studies. And what we're very interested in doing is moving on and learning more about epidemiology. You know, where are the, you know, what is the prevalence of the problems that we see? And exactly what parts of the drilling process might cause them or might not cause them. Okay. So what we're going to do now, I'm going to let Michelle talk about our study, which we generally do. She does all the interesting stuff. She's going to talk about the animals. And at the end, I'm going to come back and talk a little bit more about policy relative to what we've learned. So I'm going to let Michelle take over now.
Why did we start doing this study? How did I get into this? I started hearing stories about what was happening to animals out there, and as a veterinarian, I was wondering, are these true stories? You know, what's the bottom line on them, and what are the facts, if there are any facts behind them? And I was also wondering, you know, what's happening to the animals, and could that possibly somehow happen to humans too? So I think what's important here is to think about animals as sentinels. I'll also be talking about children as sentinels too. We have come to see children in a family and a household becoming sick first. Well, first talk about animals. Because animals are often at home, especially livestock. They're the ones that are more constantly exposed, so they have higher exposure rates than people. Their breeding schedules are such that they breed more often and their generation times are shorter. So because of those two things, we will see health impacts sooner and more intensely. Getting back to the children, which I think I'm going to have to make another slide or put the information on this one. But children, if we look at households and the cases we have that have children, typically what we see is that children become sick first. And so why would that happen? That happens because children have higher exposure rates than adults. Now, why is that true? That is true because children eat more for their body weight per pound than adults do. They also have higher metabolic rates. So for those two reasons, children have higher exposure rates. Okay, so Robert just mentioned this last bit here, how case studies can be useful, so I won't repeat that. We're often asked about prevalence, and Robert mentioned that too. So people always say, well, you know, what are the chances of these problems you're talking about, health problems happening to my animals or to me? Our study really does not answer that question. This is not a study that's going to answer the question of prevalence. Okay, so that's important, first thing. The second thing is that we are not determining cause and effect with this study. So those are two things this study does not do. But what can our study do? This study associations between drilling events and contaminated reports. So those are really strong points, and I'll build on that. Okay, so for our study, what we started off doing were initial interviews with people. They were actually quite lengthy, and we chose animal owners. And I wanted to pick cases where animals were involved because I'm a veterinarian. I wanted to find out what was happening with animals. I came to find out that people were getting sick too, so we included people's health also, the owner's health. Production animals were typically cattle. That's probably the largest number of animals that we have in our study, and most of those are beef, but we've also lately been picking up more dairy herds. We also have chickens and goats. As far as companion animals go, we have cats and dogs mostly, but there are also horses, goats, as well as llamas. And we do have some people documenting wildlife, mostly fish and deer, also other species. Once we've completed the interview, we asked for all the health records, both the animal health records as well as the human health records. I asked for them 5 years before drilling, started and up to the time of the interview and also following the interview. We also asked for all the environmental testing results that are available or that were done. Some people do have all of these. They've done all of them. Some people have not. Mostly everyone has done water tests one way or another. We also asked for drilling information. We asked for the dates when drilling took place, when fracking took place, processing, production in the area, all that sort of information. Robert has helped me immensely going on to the state website for complete drilling information about how many wells. We put in the location of each participant, and we get a number of well pads surrounding that site. We usually go out 10 miles, and we make maps, and people like to see how many well pads are around them. So we put all that information together, and this is the key right here, is we create a timeline of events for each case. And remember that we're talking about 5 years before and then following into the present. And from that, we can identify routes of exposure and commonly reported problems. Okay, so in the center, you can see the animals. I mentioned some of these different kinds of animals that we are documenting. You can see I've chosen the governor for you to stay here for a minute in the middle. On the outside, you can see the potential sources of exposure and the different phases of the industrial process. And I'll run through each one of those in just a minute. I just want to say something about the whole slide here. First of all, our cases, some of them have more than one route of exposure. So that's important. The second thing is that a good number of the cases, approximately 3/4 of them, have reported that their well water quality and or quantity changed following drilling and or hydraulic fracturing. Okay, and then we've got 1/3 have told us or reported or we've seen on the timeline where the exposure was wastewater, and another third have reported air quality changes. A lot of that involved here, but some of that involved here and here as well. Okay, so let's run through these. We just mentioned well water quality, quantity changes, the drilling fluids, or drilling muds or fluids, whatever you want to call it. Pits are usually lined, they can leak, or they can spill. The drilling fluids can overrun the well pad by blowout. With the storms, there can be runoff from the well pad. This is a really frequent one. People will tell me, especially people with livestock, that their animals will be grazing just below well pads, and there's oftentimes runoff during storms, and their animals are exposed. Flaring and venting, the difference here is that the gas is being released in both cases, but here it's being burned as it's being released, and here it's not. And this can be, again, intentional or unintentional. Okay, with hydraulic fracturing, again, the same thing with water quality or quantity change, fracturing fluid release from holding tanks. We'll be talking about a case of that. They can overrun the well pad during the blowout, they get stormwater runoff, and pacing failures can lead to water quality changes. And wastewater impoundments. Some of these impoundments are quite large, some are smaller, but oftentimes they're lined, and there can be leaks or spills, impoundments not contained. And I just spoke with someone the other day who told me that she was walking her dog, and her dog actually ran and jumped into an impoundment. There was no fence or anything, and she told me that it wasn't sort of like a thing that the dog couldn't get out of. Her dog actually could not get out of the impoundment. So she jumped in to the impoundment to rescue her dog. And she, it was like listening to a horror story. But that really hit home to me, because I've heard this oftentimes. People will say they'll find a dead deer in the impoundment or other kinds of wildlife. People are sometimes telling me the small animals have gone up to drain trauma, but that was the first time I ever heard of a dog jumping in, and then a person jumping in too. Spread on the road in New York, our DEC, and in our supplemental draft environmental impact statement refers to wastewater spread on the road as beneficial use. They say it's good to use for dusting in the summer and for icing purposes in the winter. That may be so, but what we've heard from a number of people is that the wastewater spread on the road in many different, in fact, all different weather conditions, and people sent me pictures of wastewater trucks spreading the stuff in the pouring rain. Wastewater has been dumped on property into creeks, streams, rivers, and lakes, and of course injected into deep vertical wells, and misting via aerators. So they have aerators in here. I don't know if you can see them very well in this shot, or this pond even has them. But oftentimes they look like little geysers in there, and what they do is they help decrease the volume of the wastewater impoundment, and that's a good thing. But the two bad things that occur from that are what's left in here becomes more concentrated, and there's stuff that goes off into the air, the volatile organics, and so that's not good. Stormwater runoff from the impoundment can also occur. Okay, and this is the last phase that we have listed: processing and production. Compressor stations can malfunction, making very, very loud noise, and also spewing what we've heard is some sort of oil into the air. Pipelines can leak, condensate tanks, again, there can be venting, and there can also be spills. And I just want to make one comment that these are our sources of exposure for the cases that potential sources of exposure for the cases that we have. There are other sources of exposure. We were at a meeting recently in Washington, D.C., the Institute of Medicine, and then at the CDC. And what was brought out there, it's very important for everyone to hear, is that the frac sand that's used, the sand that's used for fracking, has to be mined. And oftentimes now what we're hearing is for the people, the workers, especially for the workers, but also for the communities that live around these frac sand mining places, are becoming, having this silica dust in their lungs and developing silicosis. So that could possibly be another source of exposure. It's not, but it's not one of our cases. Okay, so this was probably the most dramatic case that we were involved in documenting. This occurred in Louisiana in April of 2009, where 17 previously healthy cows died within 1 hour following following exposure to fracturing fluid. These pictures were taken by someone on the site as it was occurring. Okay, so what's important about this case is this, the 1 hour. And this is what caught my eye when I first heard about this case. Because usually cattle die from exposure to petroleum hydrocarbons within days, not hours. So usually we hear typically of 1 to 3 days, but not an hour. So something else is going on here. The symptoms that were reported gastrointestinal tract. Cows will regurgitate, or what we would call vomit, and as they do so, then they inhale it into their lungs, and they develop an aspiration pneumonia, and one of the signs of that is pneumonia in the mouth. On the final necropsy report, the most likely cause of death is listed as respiratory failure with circulatory collapse. And even though petroleum hydrocarbons were found in the small intestine, the lesions in the trachea, lung, liver, and kidneys indicated the presence of toxins. So there was actually two quaternary ammonium compounds that were found in the fracturing fluid that these cows were exposed to, and it was tetramethyl ammonium, and that compound could cause lesions similar to this, as well as these medical signs. Okay, so these are the other cases that I'll briefly mention, which were exciting. Right now we have over 30 cases I could talk about, but we thought we'd talk about or mention these because these were interesting in that farmers sometimes don't keep all their cattle in one place. They keep them on different pastures. So when an event occurs, if it occurs in one place, it affects this part of the herd and not the other part of the herd. So in the first case, part of the beef herd was exposed to wastewater after the impoundment liner was allegedly slit. This is according to the farmer. In that case, the well pad was up high, the impoundment was up high, and it ran down the pasture and into the pond, and that was the area where the cattle were grazing. The pond was the source of water. That farmer had a number of his cattle died during that time, and he had stillborn and stunted calves at a much higher rate than he'd ever experienced before. The unexposed cattle, so he had another part of his herd was in a different pasture. They were not exposed to the wastewater at all, and those cattle, there was no change in health. The second case I'll mention was part of the beef herd exposed to a creek where wastewater was allegedly dumped. In this particular case, again, the farmer lost cattle, but he also had a good chunk of his herd fail to breed back the following spring. The unexposed cattle, he had two separate areas where other cattle were capped. They were not exposed to, they weren't on the creek side though, and they basically had no change in health. I believe there was one cow that failed to breed back in that case. And then the last case was a dairy herd that was exposed to affected well water after a casing failure. That farmer experienced reproductive problems with his cattle. He had abortions and stillbirths and failure to breed. He also experienced lameness, mastitis, and drop in milk production. So all these things, again, when I talked about the timeline and looking at things that were typical before drilling and then post-drilling, I always ask, what were the rates of these things, medical issues? Did you have any medical issues? What were the rates? And then I like to compare them afterwards. For his unexposed cattle, he had a chunk of his dairy herd that were kept away from the well water. They had pond water for their source on another pasture. There was no change in health. Okay, so our results, I just would like to mention, and I think Robert will go into this a little bit more. He talks about, he's going to come back on and talk about some more stuff. We found no definitive link. I think the thing that surprised us was how hard it is to find any definitive links. And we believe that's because we don't really know what all the chemicals are that are used in drilling and fracturing. We don't know what the interactions between the chemicals are in drilling and fracturing. People oftentimes concentrate on the fact that we don't know what the chemicals are, but there's this interaction between the chemicals too. And for me, looking at my cases, I oftentimes wonder what are the interactions between the chemicals and what's already in the environment. And for those of you who have read the paper, I'm going to be referring to case 3, where we had sulfate at high levels in the soil, and we had a lot of reproductive problems. Selenium could be affected by the sulfate. A necropsy was done in that case, and they found low selenium levels. So there could be a possibility of the sulfate decreasing the absorption absorption of selenium, and that's where I'm getting at with, we don't know what these interactions are. The other thing with the definitive links that makes it hard is we don't have complete testing. Most of our cases had they had a little bit of testing. Most of it was post-drilling. The pre-drilling was very, very inadequate, if done at all. Post-drilling was also not complete. So testing is a big deal. And then another issue too is the non-disclosure agreements. We don't have definitive links. There might be definitive links out there, health impacts, but there are things that we are not, they're not available to us. So getting onto the health changes after drilling that we determined, the big one that stuck out when we did all the numbers and all the totals was reproductive problems. And that was true with both production animals or food animals and companion animals. Again, that was failure to breed, abortion, stillbirths, and failure to cycle. That was the big thing. There were other problems too, but this was the most, the highest one. In humans, so what was going on with the owners? They also had a long list of medical problems, but when I added up the numbers, these are the things that came up most. So burning of the eyes, nose and throat. People complained about severe headaches, nosebleeds, rashes, gastrointestinal symptoms. People talked about nausea, vomiting, diarrhea, and cramping. Okay, so again, we're going to refer back to the paper. In our paper, now we've got over 10 herds. Only one of those herds was actually quarantined due to an exposure due to drilling. Okay, but what's important to remember that even though only one herd was quarantined, all the herds had exposures. All the herds that we documented had exposures. It's also important to remember that the plants on the farms have not been tested before harvest, and the food-producing animals have not been tested before slaughter. The farms in areas with known exposures are still producing food products. This area of food safety, when we go to speak anywhere, is the thing that we get the most questions about. In fact, I've had people call me and be really worried about where they're getting their milk or where they're getting their eggs, and they want me to tell them, is it safe? So go on to the next slide. Okay, so again, here are the questions these two questions are the ones that we get asked constantly. How safe are these food products from farms where known exposures have occurred, as well as other farms downstream and downwind? The answer is we don't really know. Unfortunately, we don't know because there's a lack of federal funding for food safety research, specifically that related to chemical contamination. And there's also inadequate testing, and there's also a lack of knowledge of the holding times for many of these chemicals involved in drilling and fracturing. And the holding times, I'll just say, is the amount of time that an animal is held back from slaughter after being exposed to a chemical. That chemical could be an antibiotic that I prescribe, it could be a pesticide, or it could be one of these chemicals. The second question is, how safe is the rendered flesh from exposed cattle? So what is rendered flesh? Okay, so the cow that doesn't make it onto your plate as a steak, the cow that is down, dead, or debilitated, that cow gets rendered. And that flesh is then used as feed for chickens and pigs, and it's also used for our pet food. So even if you don't eat beef, these contaminants can still make it into our food supply if you eat eggs or pork or something like that. So the bottom line is that the public health is at risk without all of the knowledge of all the chemicals. And again, I might add here, interactions between the chemicals, interactions with the environment, as well as food testing. Okay, so that's and Robert's going to pick up the finish.
Okay, so what are the issues? Well, I think everybody would agree agree that we have to understand the human and animal impacts of drilling. And we all, I think, agree that we must make our decisions based on the best science. I think the problem right now is that we don't really have very good science on the effects of drilling on human and animal health. New York has an interesting way of doing this. They proposed not to do anything, and the rationale for not to do anything is that the regulations are so good that there'll never not be any problem. However, if there's a problem, they'll try to figure it out on a case-by-case basis. The problem with that is that every state has the best regulations in the world. Canada does as well. I think we don't really know what the best regulations are, and we need to take a step back and think about it. Now, what people have talked a lot about, certainly on the anti-drilling side of the wall, is that we should follow the precautionary principle. That if there's a question about whether there's going to be there's an impact, environmental impact, then the burden of proof is on the person causing that impact. It's been argued by others that if you take the precautionary principle to its logical extreme, it's a recipe for inaction, for never doing anything. And I guess both sides have a point. But I think there is actually a middle way here, and we have a really great model for it. The pharmaceutical industry, I know a little bit about the pharmaceutical industry because I've done some consulting with them and I've talked to many people involved in drug development and testing. And they have sort of a version of the precautionary principle that they use, and I think it really is applicable to this situation. They start off by phase 1 testing, where they test whether a drug is safe. Then they go on to phase 2 and phase 3, where it's efficacy testing. Does it work? Well, what we've been doing in this process is assuming that our phase 2 and phase 3 trials of efficacy is given and skipping phase 1. Okay? So, my argument is that the burden of proof should be on the drillers, the people that are doing the drilling, but yet they should be given the opportunity to prove that it's safe. Okay, and the argument that we always hear is that it's been being done. It's been done for 60 years. Hydraulic fracturing was first done in Oklahoma, I believe, in the 1940s. It's been done safely ever since. Well, this is very similar to a drug company saying, we know that ibuprofen is a very safe drug. A lot of people have taken it for many years. So therefore, Vioxx by Merck is also safe, and we don't need to test it. Okay, that is, what I'm saying is, small-scale hydraulic fracturing of vertical wells, low-volume vertical wells would be ibuprofen, and Vioxx would be high-volume hydraulic fracturing with horizontal drilling. Okay, Vioxx, as you may know, is made by Merck, was made by Merck before it was taken off the market. It's a non-steroidal anti-inflammatory drug used for arthritis, etc. This caused a lot of heart attacks. Okay, the point is, when you change the process, you have to prove that the process is safe. And we don't know yet whether this process is safe. Okay. What are the things that are causing us to have problems studying it? Why can't we study this more effectively? Well, one of the things that has caused a problem is non-disclosure agreements. What happens in a number of cases, we have a whole list of cases that we know of where records have been sealed by agreement. Okay? So in order for a case to be resolved, person that's impacted has to agree not to talk about the case. All right. Now let's go back to our pharmaceutical company analogy. Vioxx caused heart attacks in a number of cases. Let's imagine that the families of those people were bought off or were given a settlement and not allowed to talk about it. That would have been illegal and unethical. Okay. Our view is that non-disclosure agreements in cases that affect public health are equally unethical and should be illegal. We can take this actually a step further. In the Act 13 recently passed in Pennsylvania, doctors that are treating patients that have been exposed to chemicals, perhaps in the workplace, on the crack pad, are required to sign non-disclosure agreements before they're informed of what those chemicals are. This is really a problem with many doctors. We believe that it impedes appropriate medical treatment and medical research. And it's a shame that Pennsylvania has passed this law, and unfortunately Ohio seems to be following in your path. Okay, testing. Testing, I think, is really wonderful. I think air and water should be tested whenever possible. I think some of the stuff that's going on here is really superb. I mean, looking at, many of the watersheds before and after drilling, non-drilled watersheds and watersheds that are being drilled. I think we're going to learn an amazing amount from that. What we have found, however, is that testing has been very inadequate in all of the cases that we've looked at. Pre-drilling testing has not been done in many cases, and post-drilling testing has been equally incomplete. We believe that it should include all substances that are used in the drilling process, as well as all those substances that we think probably are coming up from the shale. We have some idea of what they are, don't know all of them, but we should do better in terms of our testing. One of the problems is that we don't always know what's being used in a particular drilling operation. Now, the Obama administration has mandated, and actually the natural gas industry as well has tried to do something about this. And what they have done is to make available some of the chemicals that are used in specific wells. The problem is that the information is released after completion on their Frac Focus website. That means the information cannot be used for pre-drilling testing. And this is unfortunate. We believe that this information should be released before the frac job is done. Okay, and finally, from our interpretation of the literature, we believe that the best science tells us we should have at least a 3,000-foot radius around the well tested for water, and at least 5-mile radius for air. And I can give you references for why we believe that, if you like. Okay, now this is where the issues become very difficult, I believe. And that is in the interpretation of results. The way water results are typically interpreted is through a maximum contaminant level. That is, a concentration of a particular substance in the water is allowed to go up to some maximum level, and then when it comes above that maximum level, it's considered unsafe. Okay. The problem is, many of the chemicals that are used in drilling do not have scientifically determined MCLs. Okay? Those that do are based mainly on high-dose studies. There's a problem with that. Many of these drugs are endocrine disruptors, some of are carcinogenic. And these compounds have effects that sometimes are different at low concentrations than at high concentrations. So if you do all your testing at the high concentrations, you could miss important effects at low concentrations. Let me give you an example of that. The cancer drug, tamoxifen, that's used to treat breast cancers. It's a very good drug at high concentration. It blocks the progression of breast cancer. At low concentrations, it's carcinogenic. So low concentration and has deleterious effects on health. At high concentrations, it's beneficial. It's backwards from what we usually think about. And this is not the only case of that. There are many cases of that. If you go back to your biochemistry, your signal transduction, cell biology, you can see the reason for that is that compounds, drugs, toxicants work on different pathways at different concentrations. So low concentrations, they can have deleterious effects. If you increase the concentration, they'll hit on another system that could counteract that effect and have a different effect. So even if we know the MCL at high concentration, that doesn't mean that we're out of the woods. Okay. The other thing that Michelle touched on is that we know absolutely nothing about combinations of these chemicals. Two of the chemicals used together, what those effects are. There are very, very few studies on that. I don't mean to make fun of New York State, but we come from New York State, so we see it up front. What we do in New York State is even worse. What we've decided to do is, well, we're going to have MCLs for all compounds that are used in the drilling process. We're going to use some of them that are scientifically determined at high levels, but for the other ones, we're just going to make them up. And that's what our Department of Environmental Conservation did. It just made up a level and said, this is going to be the level. I don't know, it's not going to be very helpful. I guess it's better than nothing, but it really doesn't advance the science. So we believe that no substance should be used unless an experimentally determined MCL has been determined, even with consideration of low dose effects. Okay. Generally, I talk about a few other things here. I think this is mainly directed more toward a New York audience where we don't know much about what's going on. I think you people know more than we do, obviously. So I'm going to actually skip over some of this and get to the last point. One of the things that I always say, and that's what I really like the slide from the director early on, was that one of the big problems that we really have in New York and Pennsylvania, Ohio, is that we do have these two groups of people with a wall in between. And, I know people on both sides of the wall, and I know everybody is really interested in the same thing. People who are pro-drilling, people who are anti-drilling, we're all interested in the same thing. We want to have economic development. We want to have clean water. We want to raise our family in an environment where they'll be safe and healthy. I think we all put different emphasis on different aspects of the problem. And I would like to at least second the associate director's point that we need to start talking to each other and coming to some resolution. And one way to do that is to get data, understand the process better, and have a more open dialogue than we have. So I'll end with the statement that we always end with, and that is, without a rigorous scientific study, the gas drilling boom sweeping the world. I usually stop here and point out that this is not These are not issues that are just here in Pennsylvania, just in New York, just in Ohio. This is all over the world. We've talked to people from all corners of the world about this. South Africa, Ireland, Australia, England, Northern Ireland, Poland, etc. There are a lot of people concerned with this. A lot of people want to know the answers. Okay, so without rigorous scientific studies, the gas drilling boom sweeping the world will remain an uncontrolled health experiment on an enormous scale. And unless we do something about it, we're going to be the laboratory mice. Thank you.
Okay, thank you very much. What we're going to do now is we're going to take about a 5-minute break, give people time to write down your questions on the note cards. If you don't have a note card and want one, raise your hand, we have one to you. So we'll take a few minutes to do that. If you have to leave, please fill out the evaluations. On the evaluation form, I believe there's a portion that says, what else would you like to see for forums and speakers in the future? We're always looking for ideas.